Okay, guys, quarantine day 1. Sitting here in an empty classroom. We'll see how this goes. Let's get into it. I'm trying to make this short. Trying to make it quick. We're doing Trig Basics Part 2. On last week, when we were in session, we talked about degrees. We talked about radians. We talked about the standard form for an angle. Standard position, that is, and what quadrant each angle is going to lie in. Today we just have 2 more topics to talk about: coterminal angles and then degrees, minutes, seconds. Coterminal angles, we'll start with those. Angles in standard position with the same terminal side. So these are angles that end in the same spot but might have different degree measures. So same, let's say, terminal side. Okay. So these are found 2 ways. Again, if we look at this angle that's already graphed, this is a 90-degree angle, but it's also a negative 270-degree angle. Okay, and as far as degrees go in radians, it's a pi over 2. And it's also negative 3 pi over 2. Okay. So they're different measures, but the angle itself is the same. It's the same 90 degrees. Okay. Now, another way to think about this is, if we have an angle, so let's just draw an angle out here. Let's say that's our angle. Okay. Well, remember, when we mark these, we go from the x-axis to the angle. Okay. So that would be 1 degree measure. You could also have the negative version, or you could have it go all the way around. Because again, there's 360 degrees all the way around. So if you just go 360 degrees, you're going to be in the same spot. Okay. Which is how we find coterminal angles. For degrees, we do the angle plus and minus 360 degrees. Okay. So remember, we use theta for angles. And then you just add and subtract 360 degrees. Because that's going all the way around the graph and then back wherever you started. For radians, it's the same thing. But remember, radians all the way around the circle for radians is 2 pi. So you're going to take the angle and you're going to add and subtract 2 pi. Okay. Now, obviously, the degrees is a little easier because it's just 360. For radians, most of our radians are going to be fractions. So you're going to have to figure out the fraction version of 2 pi, depending on the denominator. All right, so let's do a couple examples. Determine whether these 2 angles are coterminal or not. Okay. Well, you just have to figure out if it's in degrees. You got to figure out if they're 360 degrees away from each other. So this one, if I take the 305 and I subtract 360 degrees, you end up with negative 55. So yes, these are coterminal. For the second one, 30 degrees and negative 170. If you take the 30 degrees and you subtract 360, because I know it's going to be smaller. If it was bigger, I would add 360. You get negative 330, which is not negative 170. Okay, and it's not, so those are automatically not coterminal. All right, and then same with the radians. Okay. Now, like I said, you have to be have a little bit of number sense when you're doing the radians. Okay. I have 1 pi over 4. Okay. And since the angle I'm checking is lower, I'm going to be subtracting 2 pi. But instead of subtracting 2 pi, because we're dealing with fractions, we're going to have to do 2 pi with a denominator of 4. So all you have to do is take the denominator you need, which is 4, and double the top number. 8 pi over 4. 8 over 4 is 2, so all we're doing is really subtracting 2 pi, but we have it in a nicer form that we could handle the fractions. So you do 1, remember adding and subtracting fractions, you only deal with the top numbers. You do 1 pi minus 8 pi, which is negative 7 pi. Denominator doesn't change. It's over 4. Alright, well these are not the same, so these are not coterminal. And the last one, checking if 3 pi over 2 and negative 5 pi over 2 are coterminal. So take the 3 pi over 2. Again, since we're decreasing, we're going to subtract 2 pi. And again, we need a denominator of 2. So instead of subtracting 2 pi, we should subtract 4 pi over 2. And you end up with negative, so 3 pi minus 4 pi is negative pi over 2. Alright, well those don't match, but the thing is, negative pi over 2 it still doesn't get us to negative 5 over 2. So this fraction it's an even lower number. So we could try it again. We could subtract another 4 pi over 2. And this time we end up with negative 5 pi over 2. So you could go all the way around the circle once. You could also go all the way around the circle twice. You could do it 3 times, 4 times. You go as many times as you want, as long as you're going all the way around. So those are the same, and these are coterminal. The next part, give 2 coterminal angles for each given angle. Make one positive, make one negative. Now again, for the degrees are always a little easier because you don't have to deal with the fractions. For finding coterminal angles for 150 degrees, you're just going to do 150 plus 360 and 150 minus 360. And you do those in your head, you can do it off to the side, you can do it in the calculator, however you want. So the first coterminal angle is 510 degrees. So 5, again, what that means, 510 degrees and 150 degrees are the exact same angle. They have the exact same terminal side. So graphically they'll look identical. And subtracting the negative angle, you get negative 210. Same thing on the other degrees. So we got negative 25. Do negative 25 plus 250 or plus 360, which is 335, and negative 25 minus 360, which is negative 385. So all 3 of those angles, 3 different measures, but they all represent the same angle, same ray. Now again, for the radians, you're going to have to add and subtract 2 pi. So I got pi over 12. And instead of doing plus 2 pi, we want to make that have a denominator of 12 because we need it easier to work with. So again, we take the denominator we need. Take the denominator we need, which is 12. Double that on top, 24. So we're going to be adding and subtracting 24 pi over 12. Adding is going to give me 25 pi over 12. And subtracting is going to give negative 23 pi over 12. And remember, radians are unitless. Same thing over here. We're going to be adding and subtracting. We need a denominator of 18. double 18 and you get 36. So we're going to add and subtract 36 pi over 18. So take negative 11 plus 36. It's going to be 25 pi over 18. And take a negative 11 minus 36, which is negative 47 pi over 18. All right, so those are coterminal angles. And pretty simple. You're just adding and subtracting 360 if you're in degrees, adding and subtracting 2 pi if you're in radians. All right, and the second thing we have to talk about today is degrees, minutes, seconds. Degrees, minutes, seconds are a way of breaking down angles. Okay. There's two ways to break down angles. You could use decimal degrees, which is just a degree with the decimal portion, or you could use degrees, minutes, seconds, which breaks it up into smaller units of time. Okay. Some angles have decimal degrees. So, for example, 47.325 degrees. And again, those can be written in what's called degree, minute, second form. Just like how kind of clocks are. We tell time with hours, minutes, and seconds. These are degrees, minutes, and seconds. The decimal portion is subdivided into minutes and seconds, just like how hours are. So 1 degree, a degree is like your hour. It's the biggest unit of time. 1 degree is 60 minutes. Just like 1 hour is 60 minutes. Okay, 1 minute, well in time 1 minute is 60 seconds, and in degree measure 1 minute is 60 seconds. So therefore you can kind of combine those and say that 1 degree is going to be 60 times 60, 3,600 seconds. Again, same thing with time. 1 hour is 3,600 seconds. The symbols that we use for degrees, minutes, seconds. The degree symbol we already know, it's that raised open circle. A minute gets a single quote, and a second gets a double quote. All right, so how do we convert from decimal degrees to degree, minutes, seconds? So in this example, we have 31.875. What you start with is you're going to start with the decimal portion. Okay. We know it's 31 degrees. Okay. The 31 degrees part is fine. It's not the decimal part. Okay. So we know it's going to be 31 degrees in some minutes and seconds. So start with the decimal form, the 0.875. And you're going to multiply that by 60. So take 0.875 and multiply it by 60. Gives you 52.5. Now this 52.5, the whole part, that's going to be your minutes. So it's going to be 52 minutes. So we got 31 degrees, 52 minutes. Now you want to take whatever's left over, the decimal part, this time it's 0.5, and you're going to repeat that process. So we're going to do 0.5 times 60, and this is going to convert it to seconds. 0.5 times 60 is 30. So therefore, if we put it all together, we're going to have 31 degrees, 52 minutes, and then this last part, 30 seconds. Degrees, minutes, seconds. Going the opposite way. Going from degrees, minutes, seconds to decimal form. It's basically the opposite. We're multiplying the decimal part by 60. Converting into decimal form, we're going to use division. So this is 73 degrees, 9 minutes, 50 seconds. First, start with the minutes. Take the 9 minutes and do 9 divided by 60. You get 0.15. Take the seconds part, 50 seconds. Divide that by not 60, but 3,600. Because again, we're converting the minutes into degrees, and that's going to be a smaller degree. Minutes are a smaller degree, and seconds are even smaller. So that's the 3,600. All right, so this one is 0.014. And then you add, basically we're just going to add those two together. So we're going to take the degrees that we already know, 73, plus the decimal form of minutes, 0.15, plus the decimal form of the seconds, 0.014. Add all those together, and you get 73.164 degrees. All right, and then this last page, practice, I'm just going to do a couple of these. I'm not going to do all of them. Maybe I'll put the rest in a separate video. All right, starting with 15.48. Again, the 15 part's fine. It's going to be 15 degrees. We just work with the decimal part first. So you're going to take the 0.48 and you're going to multiply by 60. Gives you 28.8. Now you take whatever's left over, whatever is the new decimal, and you repeat it. Take the 0.8, multiply that by 60. You get 48. So the first one we found was the minutes. Second part is the seconds. So putting it all together, you have the 15 degrees. Okay, that was the whole number in the original problem. You have 28 seconds, or 28 minutes, and 48 seconds. Okay. And we'll do this one. We'll do the 48.526. Start with the decimal portion, 526. Multiply that by 60. Gives you 31.56. And again, the numbers should make sense. Okay. 0.5 is a little more than half. So we should expect the number to be a little more than 30. Half of 60 is 30. And it is. So now you take the new decimal part, the 0.56. Once again, 0.56 is a little more than halfway. So this should be a little more than 30. 0.56 is bigger than 0.52, so we should expect a number that's bigger than 31. Okay, but not too much bigger. So take 0.56, multiply by 60, and you get 33.6. So this happens sometimes where you don't get a whole number for the seconds. Now, this is kind of one of the flaws of degrees, minutes, seconds. There's nothing smaller than seconds. There's no nanoseconds or anything. So if you end up with a decimal in your seconds, that's fine. You're just going to leave it as a decimal at the end. So we got 48 degrees. The minutes was the first one we found, 31 minutes. And then 33.6 seconds. All right, and same thing on the other one. I'll just pick 2 from here. Do these first 2. 37 degrees, 36 seconds, or 36 minutes. Keep mixing those up. Take the minute portion, 36, divide it by 60, and 36 divided by 60 is 0.6. Okay. There's no seconds on this, so we'll just write it as a decimal. 37.6 degrees. There's nothing to add on that one. The next one, the last one I'll do, 84 degrees, 52 minutes, 18 seconds. Take the 52 minutes, divide by 60. Write down that decimal. Now this is a repeating decimal. We don't have to go out too far. I'm just going to say 8.867. Take the minute portion, the second portion rather. 18 divided by 3600. Write down that decimal. This one's 0.005. All right, and lastly, we're just going to add all those together. Add this, starting with the degrees, 84 degrees, plus 0.867, plus 0.005. And you get a full degree of 84.872 degrees. Okay. Those other ones I'll put in a different video, separate video. If you want more practice, you feel free to watch that. If you think you got it, move on to the homework, which is set up in Google Classrooms. All right. Day 1, hopefully that was short. I don't know. Find out.